So here's a video about how to think about the center and the spread of a data set. So to think about the center of a data set, we use mean and median. They help us kind of find a number in the middle, a number that represents the whole set. To find spread, how far apart the numbers in our data set are, we use range or IQR, which stands for interquartile range. I'll spell that out. Interquartile range. So let's practice finding all of those things with this data set I wrote at the bottom, and then we will kind of interpret what it means. So if I have a data set, it's always a good start to order it from least to greatest first. So I'll order it 1, 2, another 2. I have 2 3s, and I have 2 4s. So we know how to find the mean. To find the mean, we add up all these numbers and we divide by how many numbers we have. So if we add them all up, we get 4, 8, 10, 12, 16, 17. So if we add them all up, we get 17, and then we would divide by 1, 2, 3, 4, 5, 6, 7. 17 divided by 7 is not going to give us a whole number, but that's okay. It'll give us approximately 2.4. So that means our mean is 2.4. To find the median, we need the number in the middle. So I would cross out from either side until I'm left with what's in the middle. This time, since it's an odd number, I don't need to do any extra work. My median is 3. Now to find the range, I'm actually going to rewrite my number set just so it's cleaner. 1, 2, 2, 3, 3, 4, and 4. To find the range, we subtract the largest minus the smallest. So I would take 4 minus 1, which gives me a range of 3. So that tells me that the distance between my largest number and my smallest number in the data set is 3. So that's helping us see how spread apart my numbers are. My largest and smallest number are 3 apart, have a distance of 3 apart. Whereas my mean and median helped us kind of find a middle or a number that represents the center of the entire set. 2.4 and 3 are both numbers that fall somewhere in the middle. And in this case, the range happens to be the same as the center, but we'll talk about that in a second. Now let's find the interquartile range, which is a bit different. To find the interquartile range, a good first step is to break up your data set into halves. So if I were to do that, this would kind of be half, this would be half. I'm leaving the 3 out because that's right in the middle. To find the interquartile range, we're going to subtract. A lot of times you'll see it written like this, Q3 minus Q1, which means we're going to take the middle of the top half, which is 4, and subtract it from the middle of our bottom half, which is 2. So Q3 would be 4, Q1 would be 2. We subtract it, our interquartile range is 2. So we have all these different numbers, 2.4, 3, 3, and 2 from this data set, but let's talk about what that actually means. Again, these two numbers are a representative of the entire data set and give us an idea of what's in the middle. These two numbers are talking about how spread apart those numbers are. So the largest minus the smallest, we get 3. And then if we look at the middle of the top half and the middle of the bottom half and subtract, we get 2. Since these numbers are relatively small, 3 and 2, that tells us our spread, our data is not very spread out. So the data is not very spread out. Our numbers are pretty close together. Now I'm going to erase the screen and I'm going to give a different example in which the spread is a bit larger. So let's wait for that for a second. So here's a new data set. Let's say that these are some test scores and the test is out of 100 points. I already found the mean by adding up and dividing by 6. And the median, there were 2 numbers in the middle, so I had to take the average, add them up and divide by 2. But let's look at what happens to the range and the interquartile range in this case. So to find the range, again, it's the largest minus the smallest. So 100 minus 15, which will give us 85. Notice how much larger our range is. The last range we had was 3. This time it's 85. So that tells us our data points are really spread out. The smallest to the largest is 85. They have a distance of 85 between them. To find the interquartile range, again, we want to look at the top and bottom half. In this case, there's no single number in the middle, so I'm not going to leave any numbers out. Here's my bottom half. Here's my top half. Here is Q3. Here is Q1. So now I subtract them. And what that really means is the middle of the top quartile and the middle of the bottom one. So 100 minus 20 will give us 80. So this is a bit different from the last data set we looked at. The mean and median are a bit smaller. These lower test scores kind of brought down the average and the median a bit. But then the range is pretty large. So this might tell a teacher that, okay, some kids really understood the material and some didn't understand it at all. That's why that spread is so large. Let me pause one more time. Let's look at specifically the type of questions that ALEKS asks you. So to finish up, let's look at this example of some questions from ALEKS. So here, the first question is, select the best description of the center of this data set over here. They give us mean, median, range, and interquartile range. Anytime we're talking about center, we want the mean or the median. So if we look at our answer choices, the average, which I know is another word for mean, the average number of books read was about 2 to 6. Well, that doesn't make sense because average is one number that describes the whole set. If we're looking from 2 to 6, that sounds maybe more like range. The average number of books read was about 12. The mean was 12. So I already know that's my answer based on the mean and median, which are the 2 descriptors that tell me about the center. And then the mean is not 25. The average is not 25. Select the best descriptor of the spread of the data set. Remember, spread, we want to look at range and interquartile range. So first one, we can tell by the median. I already know this one's wrong because I'm talking about spread and they're talking about the median, which tells me about the center. So I'm already going to cross it off. We can tell by the number of students in the class that the difference between the largest and the smallest number of books read is 25. Well, I know if I subtract the largest minus the smallest, that's the range. So is my range 25? No, it is not. Lastly, this has to be my answer. We can tell by the range that the difference between the largest and the smallest number of books is 6. That one's correct. Now let's look at what this data set could look like in a graph. Let me clear my drawings. Select the graph with the shape that best fits the summary of the values. So it says this data set is not symmetric, this one is. That's not really what I look for to really see if it makes sense. First off, I know that my mean was 12 and so was my median. So if the mean is 12, let me get my marker back. If the mean is 12, that means there needs to be some 12s in my data set, or there needs to be some numbers larger than 12 in my data set to bring up those lower numbers and make the average, make the center closer to 12. So I know this is wrong. This does have a range of, oh, hold on, what's the range of that? 11 minus 7. 5. So that also doesn't even have the right range. So the range in this is 11 minus 7, which is 5. So that tells me it's wrong. I know the mean of this. I could find the mean if I wanted to. I don't need to. I know the mean of this can't be 12. It has to be less than 12 because in this data set, no students read 12 books. No one read more than 12 books. So there's no way the center is going to be 12. So that one doesn't make sense. But this one, 15, my largest minus my smallest is 6. That tells me I'm on the right track. I have the correct range. And it looks like 12 is in the middle. It's the median. It also makes sense that the mean could be 12 if we average these numbers out. Hopefully that helps.